elastic collision. So in our elastic collision, we'll have M1 moving with some V initial, or V1, and then that's going to strike a stationary mass 2, and we'll call this V2. Now after the collision, M1 will continue moving, and we'll call that V3, and now mass 2 will be moving, we'll call that V4. And so our collision occurs, and then they move. So, because we have momentum conserved, momentum, when it's conserved, we said that PA is equal to PB. P initial, or P before, equals PA. So the initial momentum is M1 V1. This one isn't moving, so it's stationary. And what does that equal? Well, that equals M1 V3 plus M2 V4. In this case, we would know M1 and V1, but we don't know V3 and V4. And what we can do is we can solve for V3, because V3 would be M1 V1 minus M2 V4 all over M1. V3 in terms of some other stuff. Now the next part that we need is we have to remember that this is an elastic collision. When we have elastic collisions, we have kinetic energy conserved. So in this case, M1 V1 squared, because this one is 0, it has no kinetic energy, is equal to 1/2 M2 V3 squared plus 1/2 M1 V3 squared M2 V4 squared. Now that we have this, we can multiply by 2 to get rid of all of the halves, and you have M1 V1 squared is equal to M1 V3 squared plus M2 V4 squared. Because we still have our two unknowns, we can substitute in we can substitute this into V3, and then we'll be down to just one unknown, V4, which we can then solve for. So what do we see? We have M1 V1 squared is M1 times this quantity that we're going to have to square, which is M1 V1 minus M2 V4 over M1, that's all squared, plus this M2 V4 squared. We pull out the M1 squared, so M1 over M1 squared is 1 over M1. And then we have M1 squared V1 squared minus, when we multiply these out, it'll be M1 minus 2 M1 M2 V1 V4, then it'll be plus M2 squared V4 squared plus our M2 V4. Or actually, we'll multiply through by M1, so we have M1 squared V1 squared is M1 squared V1 squared minus this 2M1 M2 V1 V4 plus M2 squared V4 squared plus M1 M2 V4 squared. Now we see that we have this term on both sides, so that makes the 0. So 0 equals 0 minus 2M1 M2 V1 V4 plus, we can combine these, this will be V4 squared of M2 squared plus M1 M2. Now when we're looking at these two terms, we can factor out a V4. So we have V4 in front, and then you have negative 2 M1 M2 V1 plus V4 times this thing, M2 squared plus M1 M2. And it looks like we could have even factored out and m2. When we see this, though, what does this tell us? Well, the first solution is that v4 equals 0, that essentially this ball doesn't move after the collision. The next solution, we solve this inside piece for v4, because this is one solution. The other solution is that this internal piece has to be 0. So when we see that v4 times this term, m2 squared plus m1 m2, has to be equal to 2 times m1 m2 v1. Or we can divide out our m2, one of our m2s, and we see that, change colors, this one's dying. We see that v4 is equal to 2m1 v1 divided by m2 plus m1. We see that v4 is going to be moving in the direction of v1, that a v1 was initially moving. Now, what do we look at for v3? Well, now we can plug in v4 for v3, and let's see what we get. So this is our solution for v4, and for v3, we see we have m1 v1 minus m2 times this quantity, 2m1 v1 over m2 plus m1. And that's all over m1. So v3 looks like it's m1 v1 minus, and in this case we have 2 m1 m2 v1 over m2 plus m1 over m1. So it looks like we can factor out this m1 because every term's carrying an m1. We can factor out the v1, so it looks like v3, because I'm running out of space, v3 is equal to v1, 1 minus 2 over m2 divided by m2 plus m1. Now we can rearrange this, and we see that v3 is v1 times m1 minus m2 over m2 plus m1. So that would be our two solutions. And our two solutions are for v3 and for v4. And these are generalized solutions for an elastic collision as long as m2 is stationary and m1 strikes m2, we can see the different outcomes. So v4 will always be moving forward. Ball 2 will always move forward after the collision. But ball 1 can move forward or backward depending on which mass was heavier. So if m1 is larger than m2, m1 will strike m2, start it moving, and it too will continue moving forward. But if m2 is larger than m1, that means m1 will strike m2 and ricochet backwards. So these are our two generalized solutions for the velocities after a collision when one ball strikes a stationary one. And the results of how they move depends on the masses, the size of the masses.